In our previous video, we have looked at one of the applications of simultaneous equation, which was finding point of intersection. Okay, from your homework exercise, we had a look at the two graphs. Okay, you drew your two graphs, and what we seen was we had a point of intersection. The point of intersection is basically the solution to the simultaneous equation. Okay, and also we also have seen that simultaneous equation can be solved by drawing graphs. By drawing the two graphs, we saw two lines meet. Okay, and where the two lines meet is what we call the point of intersection, and again that is the solution to simultaneous equation. So those are the two things that we observe in the homework exercise. Okay, and then we have concluded that one of the application of simultaneous equation is finding point of intersection, or how to find point of intersection. The method is using simultaneous equation. Okay, in our previous video as well, we have seen how to solve simultaneous equation when we had similar coefficients. Example, 2x plus y equals to 10, and then let's say you have x plus y equals to 5. So notice that we have similar coefficients here. Okay, and then you will decide. So if you have similar coefficient, you are trying to eliminate this coefficient by either you add or subtract. In this case, we subtract the two equations. All right, so now what we are going to look at are coefficients that are a multiple of each other. Okay, so if you look at our equation given here, again we're using elimination method. So if you look at our equation here, we do not see any similar coefficient. But what we are going to do is, when we don't see similar coefficient, we will make one of the equation, or one of the terms here. Okay, we will make one of the terms to be the same. So in this case, if you look at it, the term x, 4 and 5, and y, 3 and 1. So which term, x or y, that has a coefficient that is a multiple of each other? It's y. Yeah, 3y is basically 3 times of y. So let's start by first labeling the equation. So you have 3y plus 4x equals to 24. That's equation 1. Y plus 5x equals to 19. That's the second equation. Okay, so we say that 4x and 5x, they're not similar, they're not a multiple of each other, but 3y and y, they're a multiple of each other. So what we're going to do is to make y to become 3y. So how do I make y to become 3y? I multiply it by 3. But when you multiply it by 3, you don't just multiply one term by 3. That's not balanced. You have to multiply the whole equation by 3. The whole equation by 3. So meaning you multiply the first term by 3, you multiply the second term by 3, and also the constant. So by doing so, this is what we get. So we get 3y plus 15x, okay, 5x times 3, so that's 15x, equals to 19 times 3, that is 57. And I will label that as 2 dash. is equation 2, but the modified, the dash represents that it's modified. Okay, so equation 1 remains, so we're just going to write that down. 3y plus 4x equals to 24, and that's equation 1. Okay, and now what do we do to the two equation? Our similar terms here are now 3y. If you compare the signs, this is positive and positive. So how to eliminate 3y? We subtract. Okay, we subtract. So by subtracting 3y minus 3y, we get 0. 15x minus 4x, we get 11x. And then 57 minus 24, we get 33. Okay, so 0 plus 11x, that's just 11x. So therefore, you get x equals to 3. Alright. So when you don't have coefficients that are similar, you are trying to make the coefficient similar by multiplying by its multiple. So here we can see that 3y and y, they are multiple of each other, so I multiply it by the multiple, which is 3. And don't forget, you don't just multiply y by 3, but it's the whole equation by 3. You don't do times 3 to the y only, because then it's not balanced. Okay, it's the whole equation. Right, once you've got, I think you know what to do from now. When x equals to 3, you substitute it in one of the equation. Let me pick 3y plus 4x equals to 24. Substitute x in here to solve for y. So 3y plus 12 equals to 24. I'm going to squeeze that in here. 3y equals to 24 minus 12. So 3y equals to 12. 3y equals to 12. So therefore, y equals to 12 over 3. So y equals to 4. So there you go. We have x equals to 3, y equals to 4. Okay, so that is how we do it for coefficients that are a multiple of the other. We will try to make the coefficient the same by multiplying it by its multiple here, times 3 to the whole equation. Okay, so we're going to look at another example. What happens when you have coefficients that are not multiples? So if you look at my coefficient for x term, 3x and 2x, they're not a multiple of each other. 8y and 7y here, they're not a multiple of each other. Okay, so but same concept, we will try to make the terms to have the same coefficient so as to eliminate one term. So let's start by first labeling the equation. So we have 3x plus 8y equals to 32. First equation. And then second equation. Now how do I make the terms to have the same coefficient? You will try to find the lowest common multiple, and normally when I do this, you would want to find the smaller number. You can either make y to have the same coefficient here and eliminate y, or you can make x to have the same coefficient and eliminate x. Okay, either or, but normally I will just pick the smaller number. So in this case, I'll pick the term x to be eliminated. Okay, because 3 and 2, those are the smaller numbers. Now we need to find the lowest common multiple. Lowest common multiple means a number that is divisible by the two numbers here. So what number would that be? I hope that rings a bell. Lowest common multiple. What are the multiples of 2? It's 2, 4, 6, 8, 10, and so on, yeah? What's the multiples of 3? 3, 6, 9, 12, 15, 18, and so on. Okay, so if you look at multiples of 2 and multiples of 3, we have 6, yeah? We also have 12, and so on, yeah? But we want to find the lowest common multiple, so it will be 6. So what we do is we we will make it to 6x by, how do I change that to 6x? That is by multiplying it by 2. So I multiply the whole equation by 2. The second equation, same thing. I want this to be 6x. How do I make it to become 6x? I multiply it by 3, a multiple of 3. So I multiply the whole equation by 3. Okay? So now what we get is 6x plus 8y times 2, 16y equals 2, 32 times 2, 64. I will label that as equation 1 dash. Okay, I'm going to multiply equation 2, the whole thing by 3. So everything will be a multiple of 3. So 6x plus 21y equals to 23 times 3. That would be 69. Okay, equation 2 dash. Alright, now we have it in similar coefficient. Now that we have similar coefficient and compare the sign, that's positive and positive, so we subtract. Subtract the two equation, and that will give me 0. 16y minus 21y minus 5y equals to 64 minus 69, so that's negative 5. So negative 5y equals to negative 5, and that should give me a positive 1. Okay? So once you found your value of y, you find x by substituting into one of these equations. So let me pick 3x plus 8y equals to 32. Solve for x, so 3x plus substitute y equals to 1. So 32 minus 8, that should give me 24. So x equals to 8. Okay, so we have obtained the answer. Y equals to 1, x equals to 8. Alright, so the same concept here is that to solve simultaneous equation, using elimination method, we want one of the terms to have the same coefficient. Alright, by doing so, we can eliminate it by adding or subtracting. Okay, so how do we do that in this case? When the coefficients are not multiple, you will try first is to pick the smaller number, and then you will try to find the lowest common multiple. Okay, the lowest common multiple for 3 and 2 is 6. So in this case, to make this to become 6x and 6x here, I need to multiply the whole equation 1 by 2 and the whole equation 2 by 3. And in that way, we will get the same coefficient, so we can eliminate it and solving for the remaining variable. Okay, so that is for elimination method. We have seen similar coefficients are not multiples, and when the coefficients are a multiple of each other for elimination method. Okay, in our first lesson, I've told you that simultaneous equation can be solved by one, elimination method, and the second one was substitution method. Okay, now elimination method is a quicker method than substitution. Alright, but for your syllabus, we still need to cover substitution method, and normally substitution method we will be using more of it. It will be a method that we'll use to solve simultaneous equation when there's linear and non-linear, but it can also be used for linear equation. So we're going to see how the substitution method works. So here, substitution method, we have looked at, this was our previous example, okay, and what we got here was, we got the answer here. It was y equals to x equals to 3, and here was y equals to 4. Okay, and our recent example we had just now was this, and we got x equals to 8 and y equals to 1. Okay, I'm going to show you by substitution method we will also get the same answer. Okay, it will also be the same answer, and you will see and you will compare which method that suits you better, elimination or substitution. Okay, so same thing, first things first, we're going to label the equation. So 3y plus 4x equals to 24, y plus 5x equals to 19. Now using substitution, basically you will substitute, you will make x or y the subject for one of the equations, okay, and whichever that is simpler. So if you compare equation 1 and equation 2, I can make y the subject here. Okay, I can make y the subject. So I will say substitute. Okay, you rearrange this. Substitute y equals to, if I make y the subject, I bring 5x to the other side. So 19 minus 5x. So substitute y equals to 19 minus 5x into equation 1. So I've used equation 2. I make y the subject here. I get 19 minus 5x, and I'm going to substitute this into my first equation, into here, the y here. By doing so, can you see that everything here will be in terms of x? Okay, so the idea is that you substitute one expression into the other equation to make all of the terms the same. So if I substitute that into equation 1, that will be 3 multiplied by y, but now your y is 19 minus 5x plus 4x equals to 24. And then what we get here, if you multiply this 3 times 19, that will give me 57 minus 15x plus 4x equals to 24. Okay, if I bring the 57 to the other side, so it will be 15x plus 4x equals to 24 minus 57. 15x plus 4x minus 11x. 24 minus 57, so that's negative 33. So my x is equals to negative 33 divided by negative 11. That will give me positive 3. So now that I get my x value, I can substitute that into the expression just now. Okay, so I had y equals to 19 minus 5x, so y equals to 19 minus 5 multiplied by 3. I substitute x straight away. So therefore 19 minus 15, y is equals to 4. Yep, so there you go. We had x equals to 3 and we had y equals to 4. Okay, we have seen this just now in elimination method, and now using substitution method we also get the same answer. So same thing for this. Now if you look at this, if I want to solve using simultaneous equation, this will get a bit tedious because it involves fraction. Okay, but I will show you just so that in the end later you can tick which method you prefer to solve simultaneous equation, elimination or substitution method. But this is only for linear equation. Later on when we look at non-linear, definitely substitution is the method. So now, okay, let's do the simultaneous equation. So 3x plus 8y equals to 32. First equation. 2x plus 7y equals to 23. Second equation. So now I'm going to pick one of these equations, and let's say that I want to make let's say from equation 2 substitute. So I'm going to make y the subject. So let's substitute y equals to 23 minus 2x over 7. Okay, you substitute this into equation 1. Right, so meaning from equation 2 here, I express and I make y the subject. You can pick x or y, but I want to make y the subject. So if I make y the subject, I get 23 minus 2x over 7, and I'm going to substitute that into equation 1, because by doing so all of my variables here, my y here, will be in terms of x. So everything will be in terms of x. It gets a bit complicated using substitution method because it involves fraction here, but again it will still give us the same answer. So let's have a look. So here we have 3x plus 8 multiplied by 23 minus 2x over 7, okay, equals to 32. Alright, so then this common mistake students do, they will multiply 8 to the top and also at the bottom. No, this is basically, you can see it as 8 over 1. So you only multiply to the numerator. Okay, so now 3x plus 8 times 23, that should give you 184. Yeah, 24, yes. So now 8 times negative 2x, that will be 16x over 7 equals to 32. Alright, and then next bit is that I will make it to the same denominator. How do I make this to become same denominator? Well, you know this is it has a denominator of 1. So to make it to the same denominator, you multiply by 7 and you multiply by 7 to both numerator and denominator, and that should give me 3x times 7 is 21x plus 184 minus 16x over 7 equals to 32. Okay, and then next you need to get rid of this fraction here. How do I get rid of the fraction? You multiply by 7 on one side, but you also multiply by 7 on the other side. Okay, by doing so my 7 cancels out, so that will leave me with 21x plus 184 minus 16x equals to 32 times 7 that should give me 4 and 22. Okay, now everything, you have x and constant. So 21 minus 16x, 5x equals to, if I bring this to the other side, 224 minus 184, that should give me 40. So therefore x equals to 8. Okay, I got the value of 8 when x equals to 8. Substitute into the expression we had just now. We had y equals to 23. So y equals to 23 minus 2. I'm running out of space, so I'm going to substitute my x in there. So 8 over 7. Yeah, I'm using that expression. Substitute your x into here. So 23 minus 16, 23 minus 16, that should give you 7. So there you go. 7 divided by 7, you get 1. We had earlier x equals to 8, y equals to 1. And that's using substitution method. It is longer in this case because it involves fraction. Okay, so for two linear equations, all right, elimination is a much quicker method, all right, than substitution. But for your syllabus sake, I still need to show how the substitution method works. So there you go, guys. You now know that simultaneous equation can be solved, one, using elimination method, the one that we have seen, okay, earlier, this one here, and this one, right? And you know that it can also be solved by substitution method. As you can see, we got the same answers. And the third method was graphical method. Okay, graphical method, basically you need to draw the graphs, and the point of intersection is basically the solution. Okay, guys, I hope you can follow through the lesson today. There will be an exercise on it for you to practice. Thank you.